Alright, I just realized I wasn't recording the first time, so here we're doing it again. Here's our starting material. I said this in the last video. What I drew out is probably the wrong order, and I'll tell you why while we go through. But what I did first was add a bromine. You do that with Br2, FBr3, FeBr3, which is a common theme. FeBr3 and AlCl3 is used a lot, but it forms this fun molecule which then can be attacked by one of the pi bonds, which then forms a carbocation. We can deprotonate the proton, reform the double bond, and boom, there's the first step. The way I drew it, I first added this, and I actually now think that you should have added this first. And the reason is, I think if you added this first, this is an ortho-para director, the bromine is. So realistically, it would probably add in this position more because of sterics. And further, if you add this first, this is electron withdrawing, and so it's a meta-director. And then this is a ortho-para, so then I also would have directed there. So they would have been working together to kind of put this one here if you added that one third. However, I'm too lazy to draw it again. So I'm going to show you adding this first before this. However, it really should be this way before that one. But that being said, the wrong way to do it, which is adding this first, to add that, I like to look at where the bond is being formed, break it, and then put bromines in between. Because you know it's going to form like a FeBr3 complex. It's got that's a cation and an anion here. So it can be attacked by one of the pi bonds. Oh, I'm sorry. It pops off first so this pops off to form a carbocation here, which is then attacked by the pi bond. Then again, forms a carbocation, deprotonate, reform, shaboom. Now again, this is the wrong third step, but this is how you do the step. Once again, you can just come up here, split where the bond is, and add a chlorine in there because it's a Friedel Craft. Also, I forgot to add this part of it because I forgot there was a little leg there. Still forms the same thing though. This lone pair comes down, that comes over and attaches to here. So then you form this really disgusting triple bond oxygen thing, which is really unstable, so it can be attacked by the pi bond, forming our molecule, which then forms a carbocation. Deprotonate that thing, and you get the final product. So, like I said, I think the real order should have been add the bromine, add the carbonyl, and then add the weird alkyl group, because it would have been a better directing thing. But once again, I'm too lazy to redraw it. But I showed the steps, and now you just have to follow this order, and you're good.